Good morning, students. Previously, we have discussed about the basic operations on sets, that is union, intersection and the difference. I told you to finish all the, just I am repeating the things. I am repeating what the things is. You have to complete the do this, try this and think and discuss in all page numbers 37 and 38. Even you have to finish exercise 2.2 also. And then I am concluding today the sets chapter which is there in your academic session, that is the finally one more types of sets. So we'll move on to that. That is the first one. If you go with that, that is nothing but equal sets. There is a difference between equal sets and the subsets. Already we have mentioned subset is nothing but if A is a subset of B, then all elements of A are the elements of B. If B is subset of A, all the elements of B are the elements of A. But what is meant by equal sets? Two sets are said to be equal if and only if they contain the same elements. That means elements must be same, not the number. It should be very, you have to observe very carefully. That is, two sets A and B are said to be equal if every element of A belongs to B and every element in B belongs to A. Simply we can say that if A is subset of B and B is subset of A, then you can say that A is equals to B. So all the elements of A are the elements of B and all the elements of B are the elements of A, then we can say that those two sets are equal. With some examples we will understand this. That is, if you take A equals to set of PQR and B is equals to set of QPR, we already know that in sets the order is immaterial. So it need not to be in order. We have to check the elements. So if you observe, A has the elements P, Q, R, B also has the same elements P, Q, R, order is different even though they two sets are contains the same elements. So if you observe here, A is subset of B and B is also subset of A, hence I can say that A is equals to B. Some more examples we will check that. A equals to set of 1, 2, 3 and so on and natural numbers set n. We know that here also the same application I can say, that is A is subset of n and n is subset of A. If two sets are subsets of each other, then we can say that those two sets are equal. Therefore A equals to n. If you go with A is equals to some PQRS and B is equals to 1, 2, 3, 4, once you observe, the main mistake and the wrong, the deviation what we have find is, whenever two sets are there, we will count the number of elements. In first set A we have 4 elements P, Q, R, S. In second set B 1, 2, 3, 4 we have 4 elements. We may think that both sets are equal. No, they are not equal because the elements are not the same. Hence we can say that A not equal to B. You can ask me immediately, sir, that type of sets what we can name them. So you can name them as equivalent sets. See that equivalent is different from equal. Equivalent means, I think you already know in chemistry and that all, valency. So equivalent means is nothing but the number of elements in both sets are equal, then they are said to be equivalent. The number of elements are equal. See here, 4 elements are there, here 4 elements are there, therefore they are equivalent. They are not equal. So but we can say that all equal sets are equivalent, because if the sets are equal, definitely they will contain the same number of elements. Definitely same elements means same number of elements they will get. So all equal sets are equivalent, but all equivalent sets need not be equal. That is the thing you have to remind. So here PQRS and 1, 2, 3, 4 number is equal. Both sets will have the same number of elements, but the elements are not same. So you have to remember that if they have same number of elements, they are equivalent. If they have same elements, they are equal. So we'll go with one more example with the set builder form. X says that X is a letter in the word assassination. So we have the spelling over there. And B equal to set of X says that X is a letter in the word station. So before going to that whether they are equal or not, first we will write that set builder form into roster form. That is, set A can be written as ASINTO. Why? Because the S is repeated, A is repeated, I is repeated, even N is repeated. Only the letter which doesn't repeat is T. So O, T and O. So we have to write the repeated letters only once. Hence I got the elements as ASINTO. Similarly, in the set B, if you write the letters in the word station, we'll get STAION because T has repeated. If you observe both sets, we know that all elements are same. A is there, S is there, I is there, N is there, T is there, O is there. All the elements of A and B are the same. Hence, we can say that A is equals to B. These are the equal sets. So, I am repeating, equal sets means the elements which contains the same elements, not the same number. Elements must be the same. So, now we have to go with the questions that they have given in your exercise. You have to observe which of the following sets are equal. A equals to X says that X is a letter in the word follow, FOLLOW. So, you know that what letters you have to write here. Here you have to write only the letter F and O repeated once, so only L and W. So if you observe this, the last one, the second set also FLOW and WOLF, the same letters are repeated, hence you can say that A equal to B and B equal to C and A equal to C. So similarly, how to go with the remaining problems over there. So how to complete these also like. So consider the following sets, fill up with the blanks, the statement below with equal to or not equal to. So which sets are equal? You can make them, you can use the symbol equal to, otherwise you have to sim not equal symbol. In each of the following state whether A equal to B or not. If A equal to B, you have to mention yes, otherwise no. So you can say the first one order is different but the same elements. But the second one, if you observe 4, 8, 12, 16, 4, 8, 16, 18, at least one element is not there, means we cannot say that they are not equal. You should not feel something like very kindness because only one element is different so that we can make equal. No. If all the elements are the same, then only you can say that both sets are equal. And if you go with third one, 2, 4, 6, 8, 10, they can give in set builder form also. X is a positive even integer and X less than or equal to 10. So we know that positive integers less than positive even integers less than or equal to 10 starts with 2. So 2, 4, 6, 8, 10, you have to check like that. So these are the problems first you have to finish about the equal sets. And one more is there about the equal sets. You have to state the reasons why they are not equal. So first set I will explain you the first one, 1, 2, 3 and so on 10 is not equal to X as that X belongs to N and 1 less than X less than 10. So already they have given they are not equal. Just you have to say why they are not equal. That's only the thing you have to mention. So why they are not equal in the sense, since in the left hand side 1 to 10 natural numbers are there, in right hand side natural numbers are there but they are in between 1 and 10. So in between 1 and 10 means 1 and 10 doesn't include in that set. Hence the left hand side and right hand side not equal since it contains two elements more on left hand side. Similarly, you have to finish the remaining why they are not equal. You have to say the reason why they aren't equal. So then we are moving to another types of sets, that is finite and infinite sets. So what is meant by finite set and what is meant by infinite set? Already we know the word infinite and finite. So in the sets we can say like this. If it is possible to express the number of elements of set, then it is called a finite set. That means if you simply we can say that if we can count the number of elements, if you count the elements in the set, then it is called finite set. That means the number of whatever the elements are there, it should be countable. If it is uncountable, then it is infinite set. So or else it is infinite set. We'll explain with an example. So if you take A is equal to the students of your school, you know that the students of your school will be finite. It can be counted. It can be countable. You cannot say that my school, the students of my school is infinite. So it is finite. The family members, the number of family members in your family, in your house, or what the number of books you have, or the number of pens you have, whatever it is. If you can, the objects are countable, then it is finite set. If you go with the second one, if x is that x is an even number, see, x is an even number means we cannot count. Why? Because if you start with 2, 4, 6, 8, 10, 12, 16, 18, 20 and so on, you cannot say and how many elements will be there in that set. You cannot count it. The stars in the sky, it is uncountable. So it is infinite set. So the planets in our solar system, it is finite set because it is countable. So like that you have to go with some more examples here. X says that x is a multiples of 7. Multiple of 7, you know that all 7 table you have to write. So 7, 14, 21, 28 like that and so on. You cannot write the last number in that. So that it is infinite. And if you go with the factor, x is a factor of 12. So factor of a number is always finite. You know how to find the number of factors also. So factor of 12 is finite, whereas multiple of 7 is infinite. So if a set is finite, definitely we can count the numbers in it. Is it? So finite set and infinite set, already we are very familiar with the infinite sets. That is natural numbers, whole numbers, integers, rationals, irrationals, all those. Because these are all infinite sets because we cannot count them at. So if it is finite, definitely we can count the numbers in it. The number of elements in a set is called cardinal number and it is denoted by n of a. That means if you take a example, if a is equals to set 1, 2, 4, then n of a is equal to 3. You have to read it as n of a. N of a means cardinal number of a. So at b is equals to 6, 7, 8, 9, 10, then n of b is equals to, you have to count the number of elements. That's all. That's the denotation is given by n of. So n of b is equal to 5. If they have given in set builder form also, you can write like x is a alphabet in the word India. So immediately you can write that one into set roster form. So for India, how can you write? I you will write comma, N you will write, and comma, D you will write, and we will not write I again, and we will conclude with A. So how many elements are there? 4 elements are there. So n of C will be 4. So what does n of indicates is number of elements in the set will be indicated by cardinal number. So another definition of finite set, now we can define finite set with the help of cardinal number. How it is? If a cardinal number of a set is a definite whole number, then it is a finite set. So if they have given the cardinal number 3, yes, it is finite. Cardinal number is 7, it is finite. Cardinal number is 4, it is finite, because these are all whole numbers, then it is called a finite set. And immediately you will have a doubt that, sir, if you mention the definite whole number other than natural number, why you have mentioned whole number? Whole number starts with 0. Is there any set? Is there any set whose cardinality is 0? Can you find a set whose cardinal number is 0? Yes. There is a set whose cardinality is 0, which is nothing but null set. So the cardinal number of null set, n of phi, is equals to 0. Observe, phi is null set. It doesn't contain any elements. Number of elements in the null set is 0. We should not confuse in that. Number of elements in null set n of pi is 0, where pi equals to empty braces. Okay, this is the cardinality of a number and finite and infinite. We will go with some more examples here of finite and infinite. If you see that, the first do this, if you go observe that, which of the following are empty sets, justify your answer, because justify your answer, whenever they give question like justification, immediately you have to remember that you have to give the reason for that. Simply you cannot say that it is empty. You have to say why it is empty. So set of integers which lie between 2 and 3. So we know that the set of integers between 2 and 3 is empty. Integers between 2 and 3, there are no integers between 2 and 3. Hence it is an empty set. So you have to write a line that there is no integers between 2 and 3. So that justification you have to give to prove the given set is empty. So the set of natural numbers that are smaller than 1, how can you say that is empty? Because natural number starts with 1. That means the smallest natural number is 1. Therefore it is empty. You have to say like that reason. And find the set of odd numbers that leave remainder 0 when divided by 2. You know that is empty, but problem is you have to justify your answer. So set of odd numbers that leave remainder 0, simply so many will write, yeah, no odd number can leave the remainder 0. That also is justification. Otherwise you can say that all odd numbers when divided by 2 leaves the remainder 1. You can write any, but it should be apt for that justification. So on the second, they have given all in set builder form, 4 more, and which are finite and infinite. Give reasons for your answer. This is again, so if a is equals to, they have given x as that x belongs to n and x less than 100, immediately you will say that it is finite. So if it is finite, how you can find the reason? Simply while explaining, you can say that yes, if you count the number of elements, you can say the numbers are countable, sir, they are less than 100. That you have to mention. Simply how to write the cardinal number here. For this reason, you can write that n of a is equals to 99, because x is less than 100 they given, n of a is equals to 99. That's why I have given the definition for finite set is, if the cardinal number of a set is a definite whole number, it is finite set. So for this justification, what I can give, if n of a is equal to 9, so this is a whole number. Since it is a whole number, as definitely you can say that this is finite. So similarly, yeah, the same x less than or equal to 5 they given, and this is and so on given, you can say it is infinite, and d equal to 1 2 3 4 given. See, the problem is, sir, why you are explaining all these simple things, you may think like that, but d equal to 1 2 3 4 is a finite set. If they ask give reason, what reason we will give? We'll say that they are countable. Generally knows why they are asking reasons. So for why they have asked this, because they have given the definition of a finite set in terms of cardinal number. So we have to use that. N of d is equal to 4, hence it is a finite set. Like that you have to go with. So tick the set which is infinite. I think you know you can do that. And which of the following are empty set? Justify your answer. Remember, justification is most important for all these sets. So I need to try this from you only. And the very important question, definitely it will be revolving in your brain. The students will always having the doubt that an empty set is a finite or infinite. He has given a statement that an empty set is finite. So how you can prove that? Is the statement true or false? Why? So they have given a statement. They are not saying that it is a true statement. They are asking, is it true or false? So I need from the students, from you, the proof how the empty set is finite. If it is finite, how the empty set is finite. If it is infinite, how the empty set is infinite. With general examples or with numbers, whatever you can, you have to prove, you have to check whether the empty set is finite or infinite. If it is finite, I need the proof. If it is infinite, I need the proof. You have the two chances in that. So go through that. So then we are moving to another property, the last property in your academics, in your 10th class textbook given by SCRT. So that is nothing but cardinal number of sets we are taking, cardinal number of operations. That means with an example we will go that A equals to set of 1 2 3 4 5 and B is equals to set of 2 4 6 8, and they are asking find the cardinality of A union B and A intersection B. That means n of A union B and n of A intersection B. So first we will calculate what is A union B, so that I can find the number of elements, is it? So A union B I will get as 1 2 3 4 5 and 6 8, as 2 4 is repeated. And A intersection B I will get 2 comma 4. Why? Because I have the common elements are 2. Now if you observe that A union B, how many elements you got? 1 2 3 4 5 6 7. But A has 5 elements, B has 4 elements, but I got only 7 elements over there. So how it is possible? If you observe the things what happened there, we will check each and everything. If n of A union B is, I got 7 elements, and n of A intersection A is 5, and n of B is, I got only 4. N of A intersection B I got is 2. So by observing this, I can say that definitely n of A union B means it may have the total chances are 9, because n of A is 5, n of B is 4. So if they don't give the elements, if I have given only n of A equal to 5, n of B equal to 4, this is most important bit in your competitive examination. If they have given n of A union B, the maximum and minimum values of n of A union B. What are the maximum and minimum values of n of A union B? If they have given this box only, they didn't give this example. This example they didn't give, they have given like this. That means they didn't give n of A union B and n of A intersection B. They have given only n of A equal to 5, n of B equal to 4. They are asking maximum n of A union B and minimum n of A union B. So I need that answer from you. Reason, whatever the questions I am asking to you, you please note down immediately on the book so that you can say tomorrow. I have given 2 questions up to now. The one is, an empty set is a finite set, is it true or false? Why? That should be done. And second one is, what is the maximum and minimum values of n of A union B and n of A intersection B? What are the maximum and minimum values of n of A union B and n of A intersection B when n of A and n of B are given? Repeating, when n of A and n of B are given, what are the maximum and minimum values of n of A union B and n of A intersection B? Okay, now I am moving to the next. So I will observe that some relation between all these elements, n of A and n of B and n of A union B and of A intersection B. You may observe that. So n of A plus n of B, if you take 5 plus 4, that may, because we know already in the beginning itself we can count that n of A equal to 5 and n of B equal to 4. So from that, definitely I can say that if I add those two, 5 plus 4, and that is equal to 7 plus 2. So if you take some more examples and check whether this relation works out or not. If this relation works out, then I can generalize like n of A union B plus n of A intersection B is equal to n of A plus n of B. The students, I am giving that you can check any n number of examples. Mathematics students should not obey whatever there in the textbook, and that means whatever they, without proof they should not obey anything. So with proof, if they didn't give the proof, just you have to check it, as we did the proofs in logarithms. So n of A union B plus n of A intersection B equal to n of A plus n of B. We have done this proof by using the numbers. But without numbers, can you solve? Can you find some other formula to prove this? Just you can think of. So if so, for so many examples we get the same answer. So I can say that n of A union B plus n of A intersection B equal to n of A plus n of B. This is the relation between A union B, sorry, n of A union B, n of A intersection B to n of A and n of B. So you can find out one from the one unknown from 3 known values, that is different. And one more question is, if A and B are disjoint sets, then what about n of A union B? We know that definitely n of A union B becomes n of A plus n of B. Why it becomes? Because if they are disjoint sets, we know that A intersection B equal to null set, and already we proved that the cardinality of a null set is 0. So A intersection B becomes null set and n of A intersection B is equal to 0. So I can say that if A, B are disjoint sets, then n of A union B equals to n of A plus n of B. And I can go some observations over here again. If A is subset of B, then what about n of A union B and n of A intersection B? I need the answer from you with an example or with you on your own. If A is subset of B, if A is contained in B, then what about cardinality number of A union B and cardinal number of A intersection B? This is also you can apply for maximum and minimum values of A union B and A intersection B. So these are the final operations what do you have in your textbook in academics, and finally last exercise should be done with you. See that state which of the following sets are empty or which are not. Already that's there, we have done there. And see the beauty in questions that have been asked in that. First Roman, if you go with the third one, x says that x is a natural number and x less than 5 and x greater than 7. So we have to check whether there is a number which is less than 5 and greater than 7. If it is not there, just you have to say it is empty. So similarly, which of the following are finite and infinite? You have already that we have discussed how can be defined with cardinal number of cardinal number of a set. How you can define the finite or infinite sets? So you can justify those the things. And second Roman, third Roman is going with the same. So if you go with the last example that we have already done, see, does not contain 9 elements and it contains 7 elements only. Why? Because we are removing that, we are subtracting that A intersection B elements, the common elements, because we will not repeat it again. Hence we are not common elements. Then we got the 9 elements. Suppose what I am asking is if A and B are disjoint sets. That's why we got the think and discuss second question. Why that A and B are disjoints? If they A and B are disjoint sets, then their N of A union B. Why this question arises? Because generally if N of A we have 5, N of B is 4. Whenever you ask A union B, generally the students will think that 5 plus 4 9. It is possible when and only they are disjoint sets, because if they are disjoint sets, we will not repeat the things which are common in both sets. So while we will not repeat the things in common in both sets, then we can say that both the number of elements in A plus number of elements in B will becomes number of elements in A union B. So it is possible when and only A intersection B is null set, that means A, B are disjoint sets. So dear students, what I want from you is I need to get so many things. So 2.4 up to exercise 2.4 each and everything. Do this, try this, think and discuss, even examples. Already mentioned that do this, try this, think and discuss, and example should be in, otherwise example should be in one notes. Do this, try this, think and discuss, and exercise problem should be in another notes. You have to maintain that, and in that, and we have to check one extra thing, one new proof, one new thing that we have learnt today in this chapter. At least in this chapter you have to go with that. So that I have asked how to prove N of A union B plus N of A intersection B equals N of A plus N of B, and similarly how you can prove that empty set is a finite set or infinite set. I've asked you that, and not only that, if you have learned more, we can discuss and you can participate in that. And still if you have any doubts regarding the chapter sets, definitely you raise, we will get back to you. Thank you one and all. Thank you.